Today we are going to look at histogram. Histogram. So let's look at the following example. We want to draw a histogram. The distribution by age of 18. Example. The distribution by age of 18 patients, by age of 18 patients attending in clinic for rheumatic disease during Sunday is shown. Disease during Sunday is shown in the table below. Is shown below. Right, we are given a table here. Alright, here we have age in years. Then here we have frequency. Then for age you have 10 to 14. We also have 15 to 19, 20 to 24. Then we have 25 to 29. We also have 30 to 34. Then for frequencies 3, 1, 5, 2, and 7. Then the question is saying draw a histogram. Draw a histogram. Right. When you are given this type of a question, the first thing you are supposed to do is to see whether these classes are real classes or apparent classes. What do we mean by real classes and apparent classes? The number that we have here must be equal to the number that we have here. The highest class limit for this class must be equal to the lower class limit for the next class. So if they are not equal, these classes are called apparent classes. But under normal circumstances, we use real classes to draw a histogram, because we can't plot a histogram with range 10 to 14, 15 to 19. It will be a bar graph. The difference between a histogram and a bar graph, a histogram is continuous bars like this. We have continuous bars. So we can't have continuous bars. When we have 14 and 15 here, there will be a gap of 1 unit. But a bar graph, we can have bars with a space here. So for a bar graph, we can draw a bar graph using these intervals, because this can be 10 to 14, 15 to 19, then 20 to 24, right? So in this case, we have to change from apparent classes to real classes. So how do we change from apparent classes to real classes? How do we change from apparent classes to real classes? We have to come up with a table like this. So this is our frequency column. So classes frequency, right? For here we have to take the difference between the lower class limit here and the upper class limit here. So if we can use this one, we have 15 minus 14, we get a difference of 1. If we say 20 minus 19, we also get a difference of 1. Then if we say 25 minus 24, we get a difference of 1. 30 minus 29, we get a difference of 1. So for us to change from apparent classes to real classes, we divide this 1 by 2 so that we get 0.5. So what are we going to do? For all the lower limits, we are going to subtract 0.5. Then for all the upper limits, we are going to add 0.5. So for lower limits, we are going to add 0.5, right? For upper limits, we are going to add 2. So for lower limits, I said we are going to subtract, then here we are going to add 0.5. So we are going to subtract 0.5 from 10. What are we going to get? We are going to get 9.5. Here, if we subtract 0.5, we get 14.5. If we subtract here, we get 19.5. If we subtract here, we get 24.5. If we subtract here, we get 29.5. Right? Then for upper limits, we are going to add 0.5. If we add 0.5 here, we get 14.5. Then if we add 0.5, we get 19.5. If we add 0.5, we get 24.5. If we add 0.5, we get 29.5. If we add 0.5 here, we get 34.5. Alright. And our frequencies, we have 3, 1, 5, 3, 1, 5, 2, and 7. Right? You can see clearly that here we have 14.5, 14.5, 19.5, 19.5, 24.5, 24.5, 29.5, and 29.5. So now we can be able to plot a histogram from this information. These now are real classes. These are real classes. Right? So for our histogram, we can use real classes to plot. Now we can have our Cartesian plane. Since we are not starting from 0, we are starting from 9.5. Here we can use this. Then we start from 0.5 up to 34.5. Then for our scale, we can use for frequencies, we can use 2, 4, 6 up to 8. Then for our age, which is our classes, we can use again 5, 10, 15, but from 9.5. Starting from 9.5, 14.5, going, here we have 9.5, 14, 19.5, 24.5, 19.5, 24.5, then 29.5, then 34.5. Right? Then here we can use, since we have 1 up to 7, we can use 2, 4, 6, 8, 10, or else we can use 1 from 0, 1, 2, 3, 4, 5, 6, 7, since 7 is our maximum number. Then you label your graph. Here we have age in years, age in years. Then we have our frequency here. Right? So first we have 3, 9 to 14.5, we have 3, 9.5 to 14.5, we have 3 here. Right? From 14.5 to 19.5, we have 1 unit. So this is continuous. Then from 19.5 to 24.5, we have 5 units. 5 units. Then from 24.5 to 29.5, we have 2 units. Then last one, from 29.5 to 34.5, we have 7 units. Right, so this is how we plot a histogram, right? Remember, if you are given apparent classes, you have to change them to real classes using this method. So let me give you a question to attempt. Let me give you a question to attempt. Right, question. The time taken by a large group of students, the time taken by a large group of students to solve a particular mathematics problem, to solve a particular mathematics problem is given below. Right, so we have a table again. Right, here we have time in minutes. Time in minutes. Then we have frequency. So for time we have 10 to 12. We have 13 to 15. We have 16 to 20. We have 21 to 30. We also have 31 to 50. Then 69 20, 10, 60, right? So we are required to draw a histogram to illustrate this data. Draw a histogram, right? So try to attempt this question. Remember to change from apparent classes to real classes, right? Thank you. See you in our next lesson.